Hello, welcome back. Previously, we have looked at how to read in data files and organize data into tabular format using pandas package and perform various functions. Today, we are going to learn to do some plotting using package called Plotnine. Plotnine is based on our package called ggplot2 and is based on the theory of grammar of graphics. The references are provided here. The ggplot graph is made of two essential components. So one is data, geometric object, and aesthetics, and then there are some optional components. And let's look at them one by one. So obviously, data has to be organized in a tabular form, in a data frame where you have observations as rows and then you have variables as columns. Then you want to see how to plot these data points onto a graph. So do you want a scatter plot or a line plot or a bar plot and so on? So that comes under geometric objects. And the third essential component is aesthetic mapping of the data. So where do you want to plot these data points? Like what goes on x-axis versus y-axis? Do you want to use different shapes, or if you want to use line, do you want to use different colors and so on? And this brings us to our next component, which is called scale. So scaling is about how you assign those aesthetic mapping to your data points. For example, I want to say like a data that belongs to male group is plotted as red versus data belongs to female group plotted as blue. Or if you want to perform some, let's say, logarithmic transformation of your data before you plot it. So let's look at how we make a graph using ggplot. So ggplot is based on this color palette model where you start with some initial layers and then you add more and more metadata layer and annotations until you have a masterpiece that you desire. So for this demonstration, I'm using a free data set called Gapminder data from Kaggle. And we will be using two packages. So first one is the same, as before, pandas package that we are importing as PD. And the second one is Plotnine that I'm importing as P9. And we have seen how to read in data using read CSV function from pandas, as well as cleaning up data by removing any missing values in the file before you do the plotting. And just pay attention to if you look at the glimpse of top few lines, what are the different columns called in the data. So we got like country, continent, year, and life expectancies and so on. So let's see, I want to plot year versus life expectancies from this data. So the code to do this plot will be, so I'm calling my package name called P9, and the function that I will use is ggplot. And here I will describe what my data is. So data is already stored in a data frame called Gapminder that you just saw. Next, I will add aesthetic mapping. So aesthetic mapping for this will be done by using this function called AES. And here I will tell that on x-axis, please plot the column here. So this is the same column from your data table. And on y-axis, I want life expectancy. So which should be exact name as it is in your table. And that's it. So that's my second layer. Now, what is the third essential layer? So third layer was what type of plot I want. So I want a point plot. So the function for that is geomPoint. So I'm just enclosing the entire code snippet into brackets so that you can write it in multiple lines. And the other thing you will notice is that each line here is separated by these plus signs. So that this is what defines the different layers of our code. So we got data and the aesthetics and the geometric object. So yeah, just to recap, so that's our final code, and these are three main components including different layers of our code. And once you execute this code, that's the kind of plot you will get. So as you can notice, the labels on the x and the y axis are the same as your column names, and all of the data is plotted as points. Now let's see if we can add some more meaningful labels to our x and y axis. So how can I do that? I'll just add one more layer to my previous code. So I will just use again plus sign to add the next layer, and the next layer I will call as labs for label, and on x-axis I want to call this year still, and y-axis I want to call it live expectancy. So that's my x and y labels, and then I can also add a title to this plot. So I'm just calling it plotting demo. Okay, so this was my previous code, and I've just added one more layer, which is about the labels to this plot. So let's see how what changes after you execute this code. So there you go. So now you can see the x and y labels have changed, and then we also have a plot title here. Okay, now the plot is very black and white, and let's add some colors to it. So as you can see, let's see if we can use any other variable from our data to add colors to our plot. So I want to use the column called continent to add color. So what I'll do is I'll just go to my aesthetics section, and we'll just add color. So you will start with comma, and I'll just add color by continent. So you will add this new scale in your aesthetics section itself, and let's see how this plot looks like. There you go. So you see now my black and white data the black points are now changed into colored points, and then you also have the legend that was added automatically to the plot. So now you start getting some more information from your plot. Let's do one more thing. Let's change the size of the dots as well, and this time I will use the second column called GDP to add the size information to my plot. So there is the updated code. So what I've done here, so here you had previously color by continent, and now I've also added the size by GDP, and GDP was one of the columns in your table. So now you see in your plot, now you start getting more information than just dots in between x and y. And so similarly, you can have more type of plots done using ggplot, Plotnine. For example, you could do a line plot, and you could do subsetting of data and highlight that data. And then there are some more optional information that you can add to your graphics that we would look at in the next class. And these are looking at different coordinate system, adding facets, and performing some statistical transformation of your data. So we'll come back to this in our next class. Thank you for listening.